Over the past year, reports about severe vibrations on China's high-speed rail have spread widely. Numerous individuals have uploaded videos showing the train car shaking during travel, with many passengers expressing how nerve-wracking such experiences have been. The truth behind these vibrations has now come to light. It turns out that China can no longer produce high-quality wheels for its high-speed trains, and the hidden reasons behind this revelation are even more startling. Recently, Chinese online media began resurfacing older stories about Japan and Germany halting their supply of high-speed train wheels to China. Headlines such as, "Japan and Germany tore up a 570 million yuan contract, halting wheel supply, now begging China for mercy. China has long been prepared," and "Japan lost billions in contracts and is furious," flood the internet, creating a chaotic and contradictory narrative. If Japan and Germany themselves tore up the contracts, why would they be furious over lost deals? And if China had long been prepared, why is there so much anger over claims that Japan and Germany has significantly impacted its high-speed rail industry? An online search reveals that Japan and Germany announced in March last year they would stop supplying high-speed rail wheels to China, canceling contracts worth $80 million US. This news initially attracted little attention within China, but resurfaced for heated discussions online this September. What transpired during this period? A propaganda video released by the Chinese authorities provides some context.
The high-speed rail project is a critical initiative in our nation's public infrastructure planning. Over the years, China high-speed rail has become a globally renowned symbol of China with advanced construction techniques that many countries find impossible to match. However, what may come as a surprise is that the core component of high-speed rail, the train wheels, was long monopolized by countries like Japan and Germany. For a time, we were unable to produce our own high-speed train wheels, leaving us constrained by other nations at every turn.
The video emphasizes the critical role train wheels play in ensuring safety and speed for high-speed trains, which frequently operate at speeds over 300 kilometers per hour. Any deviation, even as small as 0.2 millimeters, could lead to major safety risks. It explains that producing high-speed rail wheels requires exceptionally high-quality steel, with ultra-pure standards such as hydrogen content below 2 parts per million and uniformly distributed inclusions. In addition to producing such high-grade steel, manufacturers must also tackle the intricate and complex process of wheel production. Once completed, these wheels undergo comprehensive testing to ensure the dimensions, hardness, and internal conditions meet strict standards before they can be approved for release. The video stressed that due to the complexity of manufacturing high-speed train wheels, many countries and companies classify wheel technology as a strategic core secret. Strict policies such as no patent applications, no academic publications, and no technical exchanges make it nearly impossible for outsiders to access this knowledge. This secrecy has allowed industry giants from Germany, Italy, France, and Japan to monopolize the global market for decades, exporting wheels to China at prices over 10 times higher than regular wheels. According to Chinese sources, these hurdles have now been overcome domestically. The video claims that after years of concentrated effort, China has successfully produced 2 models of domestically manufactured high-speed train wheels, Blue Dolphin and Golden Phoenix, breaking the foreign monopoly on China's high-speed rail wheel market. The video further boasts that China has developed high-quality wheels that address the shortcomings of imported products. It claims that these wheels surpass foreign alternatives in hardness, heat resistance, and wear resistance. Additionally, China's high-speed rail wheels are set to exceed imported products in material design, metallurgical quality, overall performance, testing techniques, and intelligent manufacturing, achieving international advanced standards. The video also states that Chinese wheels have passed certifications in Germany and South Korea and are now being exported to countries such as South Korea, India, and Germany, marking a significant transition from import reliance to becoming an exporter. This propaganda video, however, was released shortly after Japan and Germany announced their suspension of high-speed rail wheel supply to China last year. Interestingly, it was published in Chinese on YouTube, targeting an international audience. The intent seems to be clear. The Chinese authorities aim to shape public opinion overseas, promoting the narrative that China is capable of producing high-quality high-speed rail wheels. This effort was likely intended to protect the reputation and sales of Chinese high-speed rail systems in international markets. At the same time, authorities sought to downplay the news domestically to avoid public panic, which could exacerbate the already significant financial losses of the high-speed rail sector. Over the past year, however, an increasing number of passengers have reported severe vibrations in high-speed train cars. The cause has now become apparent. Following Japan and Germany's suspension of wheel supply, China switched entirely to using domestically produced so-called high-quality wheels, leading to these issues. Online disclosures reveal that high-speed train wheels require maintenance after 1.2 million kilometers and must be replaced after 2.4 million kilometers. Since Japan, France, and Germany stopped exporting machinery for wheel production and maintenance, China has no choice but to replace existing wheels with domestically produced ones originally designed for overseas Belt and Road projects. Previous reports have highlighted that domestically produced axle steel and wheel steel in China can only support train speeds up to 140 kilometers per hour. Using such materials to produce acclaimed high-quality domestic wheels for trains running at speeds over 300 kilometers per hour presents significant risks. Vibrations are unavoidable, and prolonged use could lead to catastrophic consequences. This also sheds light on why Chinese authorities, despite previously claiming that domestic wheels had achieved international advanced standards and were superior to imported products in all aspects, are now lashing out at Japan and Germany for halting their supply of high-speed train wheels. But why did Japan and Germany stop supplying wheels? Was it merely an act of retaliation for China's alleged theft of high-speed rail technology and restrictions on its development? To answer this, it is essential to revisit how China acquired its high-speed rail technology. Whether through theft or deception, let's examine what this teacher has to say next.
德国和法国都有这个技术。
Currently, Germany, France, and Japan have high-speed rail technology. China approached Germany, offering an order of 1,000 trains on the condition that the technology must be transferred. Germany refused. So China turned to France, proposing the same deal for 1,000 trains. France hesitated, saying they would consider it. Then China went to Japan's Shinkansen, which was using 1984-era technology, and Japan agreed. Japan ultimately secured the order, prompting Germany and France to reconsider. Seeing Japan's deal, they also decided to transfer their technology. As a result, our CRRC, that is China Railway Rolling Stock Corporation, ended up with technologies of Germany, France, and Japan. We effectively saved ourselves 400 years of development by spending money and trading market access for technology. In the past, we used to spend 200 million euros, about 2 billion yuan, to purchase a single train. After the technology transfer, CRRC could manufacture the same train for just 200 million yuan. Why? Because we no longer had to pay for the research and development costs associated with patents. Additionally, Chinese engineers have lower labor costs compared to those abroad, so we could produce a train for just 200 million yuan. What's the situation now? Now, Germany is placing orders for high-speed train cars with us. Why? Because China's manufacturing costs are cheaper. It's not cost-effective for them to make the trains themselves, so they outsource production to China. After all, the technical standards are still set by them, and we simply follow their German standards to manufacture. This is the development path of high-speed rail. If we had relied solely on independent research and development, it would have taken far longer. Consider the components, materials, and software essential for operation. How long would it have taken to achieve all that? We couldn't afford the time. Once again, this teacher justifies actions like breaching contracts and intellectual property theft with a sense of moral righteousness, leaving one to wonder, what is the urgency behind we couldn't afford the time, we can't wait? What exactly is so pressing? The answer becomes clear. Stealing and deceiving must be done quickly. A thief who moves slowly risks being caught. The Chinese Communist Party promised to purchase 1,000 trains in exchange for technology transfers, but never fulfilled the agreed-upon number of orders. Instead, only a fraction of the trains were purchased before reverse engineering began. The technology transfer agreement signed by Japanese and German companies did not authorize China to independently produce the entire high-speed rail system. Key components such as high-speed rail bearings and wheels, which China could not manufacture, remained excluded. Furthermore, the machinery required to produce these components was not available in China. The transfer technology and production licenses mainly covered train shells, motors, and interior fittings, components that China had the capacity to produce. Even for these, the agreement stipulated that the technology was only to be used for domestic upgrades and maintenance, not for export competition. Meanwhile, the supply of components like bearings and wheels was tied to the number of trains purchased under the agreements. Since the Chinese government unilaterally breached the contracts, Japan and Germany had no obligation to continue supplying critical parts for China's copycat products. China's blatant infringement of Japanese and German patents has deeply frustrated high-speed rail manufacturers. A prime example is how China exploited Japan's Shinkansen technology. China's first high-speed rail line, the Beijing-Shanghai route, introduced Japan's Shinkansen technology in 2004. Specifically, it adopted the Hayate model, used in Japan's Tohoku region, with a maximum speed of 380 kilometers per hour and an operational speed of 275 kilometers per hour. The Harmony and Fuxing trains currently operating in China are based on technology from Japan's Kawasaki Heavy Industries and modeled after the Hayate Shinkansen. Even before construction began on the Beijing-Shanghai line in 2003, China had already applied for international patents on the technology used in the CRH-380A Harmony trains, which were based on the Shinkansen technology. Reports indicate that China filed 21 high-speed rail patents under the Patent Cooperation Treaty, aiming for recognition in Japan, the US, Brazil, Europe, and Russia. Between 2003 and 2011, China filed 1,902 patents related to high-speed rail technology, of which 1,421 were approved and 481 were pending. However, 21 core patents were merely extensions or modifications of Japan's Shinkansen technology. This means that even before officially introducing the Shinkansen, the Chinese government had already prepared to infringe on its patents. By the time the technology transfer agreement was signed, China had obtained all non-critical elements, excluding bearings, wheels, and automatic control systems. When the first high-speed rail line opened, China had already filed numerous patents under the Harmony name, creating the impression that it was an entirely indigenous product. The audacity of filing patents even before having a high-speed rail history is something only the Chinese government under the rule of the CCP could accomplish. Japan likely tolerated this infringement in the hope that China would at least fulfill the 1,000 train purchase agreement, or at least a majority of it, but trusting the CCP inevitably leads to disappointment. Japan and Germany's decision to stop supplying high-speed rail wheels was driven not only by breached agreements and patent violations, but also by a desire to avoid being blamed for potential accidents involving Chinese high-speed rail. Take the Shinkansen as an example. Over more than 50 years, it has achieved two major milestones: no fatalities due to train malfunctions and an average annual delay of less than 8 seconds on the Tokaido line. From vehicle technology to operational management, Japan's Shinkansen was developed entirely in-house, gradually improving over decades. Its technical foundation, combined with a steadfast commitment to safety, prioritizes safety as a top consideration, with economic efficiency ranked second and speed coming third. Over more than 50 years, the Shinkansen's maximum speed has only increased by 120 kilometers per hour, from the initial 200 kilometers per hour to the current 320 kilometers per hour. In comparison, China's high-speed rail system, introduced from Japan and Germany just over a decade ago, has already reached speeds of 350 kilometers per hour. Why hasn't the Shinkansen surpassed this speed? In fact, as early as 1997, Japan's Shinkansen 955 series reached a speed of 443 kilometers per hour. However, Japan intentionally reduced operational speeds to around 300 kilometers per hour. Why? A JR Central Technical Director explains. 1. Safety concerns. Japan's geography is largely mountainous, with many Shinkansen lines passing through tunnels. High-speed trains generate compression waves at the front and expansion waves at the rear when passing through tunnels, causing discomfort for passengers due to ear pressure. Operating at speeds above 350 kilometers per hour would exacerbate these issues. 2. Earthquake preparedness. Frequent earthquakes in Japan necessitate the ability to decelerate trains effectively before seismic waves strike. Excessive speeds could lead to derailments during emergencies, resulting in catastrophic accidents. 3. Economic efficiency. Calculations by Japanese railway companies indicate that operating below 300 km per hour optimizes wear and tear on wheels and tracks, reducing maintenance costs. Speeds above this threshold result in significantly higher operational expenses. He stated, "We can't justify risking passenger safety just to save 10 or 20 minutes of travel time." Another critical piece of technology that China has yet to master is the automated control system for high-speed trains. Japan's Shinkansen employs a centralized control system to monitor and remotely manage all trains on its lines. Each route is also equipped with an automatic train control (ATC) system, which can autonomously adjust train speeds or halt operations without driver intervention. For instance, if the distance between two trains falls below 1,500 meters, both trains automatically apply emergency brakes to prevent collisions. This technology has enabled the Shinkansen to operate safely without human drivers. The Shinkansen also uses a distributed power system, with each carriage powered by its axles. This eliminates the need for heavy locomotives, reducing axle weight, enabling smoother acceleration and deceleration, and ensuring stable travel on steep routes. It also minimizes noise and vibration, enhancing passenger comfort. Furthermore, this system reduces pressure on the tracks, lowering construction costs while improving economic efficiency. With advancements in semiconductor technology, the Shinkansen's braking systems have transitioned from air brakes to combined electro-air braking and regenerative braking systems. Regenerative braking converts the kinetic energy generated during braking into electricity, significantly improving energy efficiency. This innovation positions Japan's Shinkansen as the highest quality high-speed rail system in the world. The 2011 Wenzhou high-speed rail disaster in China, which resulted in significant casualties, revealed serious flaws in China's self-developed automated control systems. This tragedy also highlighted the dangers of prioritizing speed and international reputation over passenger safety and operational sustainability. The CCP's pursuit of high-speed rail leadership has come at the cost of public safety, using its citizens as a testing ground for unproven technology. Despite initially lowering train speeds after the Wenzhou disaster, the CCP recently reinstated 350 km per hour operations under the Fuxing brand, declaring it once again leading the world. Online commentators have criticized this decision, comparing it to China's domestic aviation industry. Western standards require 250 approvals, but we take off with just 20. After all, there's no shortage of people unafraid to die. Japan and Germany face a difficult position regarding China's high-speed rail system. Continuing to supply critical components, such as wheels and bearings, would effectively support the CCP's deceptive practices. The CCP has branded its high-speed rail as a shining card to dominate the global market. The best course of action for Japan and Germany is to allow China to pursue complete self-reliance. However, both countries are well aware of China's current limitations. Domestic steel production can only support speeds of up to 140 km per hour, and its automated control systems still suffer from major deficiencies. For safety, China's high-speed rail should not operate above 200 km per hour. By pushing speeds back to 350 km per hour, the CCP risks further accidents. If such incidents occur, China might blame Japan and Germany for faulty components, despite having breached agreements and infringed patents. Thus, cutting off the supply of critical parts like bearings and wheels was not only a necessary decision, but perhaps the only viable one. As high-speed rail components near the end of their service life, China's high-speed rail system faces mounting problems, from critical system failures to paralysis of lower extremities in its infrastructure. In theory, China has two options: lower maximum operating speeds to 200 km per hour, or mend its relationships with Japan and Germany by halting patent violations and honoring breached agreements. In such a scenario, Japan and Germany may resume supplying parts. However, as long as the CCP remains in power, such solutions seem nearly impossible to achieve.